Hello and welcome to Mechanical Y. Today we will be doing a micro lesson on the law of sines. Law of sines is a particularly useful relationship when dealing with triangles. It is especially useful when you have some limited information about a triangle but you're trying to figure out more information. In particular, the law of sines relates the lengths of the three sides of the triangle to the angles inside of the triangle. So what we're going to do today is we're going to look at the law of sines, derive it given a generic triangle, and then we're going to see how it's applied and some special cases. Okay, so let's start with a right triangle. In this triangle, we have one angle that is equal to 90 degrees. And then we have an angle here, let's call it alpha, and we have an opposite side, let's call it A, and a hypotenuse, and let's call it C. In this case, we can write that the sine of alpha is equal to the opposite side over the hypotenuse. So we get the sine of alpha is equal to A over C. This is the general definition of a sine, and this is applicable to right triangles. What happens though when we take a triangle that doesn't look like a right triangle? What happens if we have some weird shape like this, where we have an angle alpha, beta, and gamma, and then we have sides A, B, and C, and we don't know whether this is a right triangle? How do we write the sine of alpha in this case? Well, here we're going to have to use a little bit of a trick, because we don't know that this is a right triangle or not, so we're going to effectively make it a right triangle. What we're going to do is that we're going to create a line, and this line is going to be perpendicular to B, and it's going to go down like this, perpendicular to B, and it's going to cut this triangle into two parts. This smaller triangle here, and this smaller triangle here. Now both of these are right triangles, and let's call this line X. Now what X is doesn't really matter because it's going to go away very soon. So now using this relationship, we can say that the sine of alpha is equal to X over C. And likewise, we can come to this side and we can say that the sine of gamma is equal to X over A. Now we have to try to get rid of these x's. So what are we going to do? Well, let's start with this gamma equation, and let's get rid of x. We solve for x, and we get x is equal to A sine gamma. Now we take this equation, and we plug it into the equation for sine alpha. Now we get that sine alpha is equal to x, which is A sine gamma, all over C. Now we can rearrange this to make it a little more easy to read, and we get that sine alpha over A is equal to sine gamma over C. Here we have part of the law of sines, but we're missing something. We're missing B and we're missing beta. So what do we do to get that? Well, let's take the same triangle that we had before with the same angles and the same sides, so it still has alpha, beta, and gamma, and sides A, B, and C. And we're going to do the same procedure as before, and we're going to drop a line that's perpendicular to one of these sides. But instead of doing it perpendicular to B, we're going to do it perpendicular to A. So we're going to draw this line here that's perpendicular to A, call it X, and now you see that we've divided this triangle into two smaller right triangles, one here and one up here. Now we repeat virtually the same procedure as we did before, and now we can say that the sine of beta is equal to X over the hypotenuse C. And we could do the same thing for sine gamma is equal to x over b. Now, just like before, we solve one of these equations for x. So we get that x is equal to b sine gamma. Now we take this equation and we plug it into the other one. And we get that sine beta is equal to x, which is b sine gamma all over c. Rearrange this just like we did before, and we get that sine beta over b is equal to sine gamma over c. These two equations now combined is the entire law of sines. So let's write it in a way that's a little easier to see. So now we have that sine of alpha over a is equal to the sine of beta over b is equal to the sine of gamma over c. And this is the law of sines for a triangle. So how is this useful? Why do we want to do this? Well, if you notice, we have 6 variables. In this triangle, we have 3 angles, alpha, beta, and gamma. And then we have 3 sides, A, B, and C. Now, in this case, if we know 3 of these values, we can solve for the other 3. So if I don't have all the information about this triangle, but I have at least 3 of these values, I can get the rest of the information that I need. Now, the only special case in this is if we have just the 3 angles. In that special case, we won't be able to solve for A, B, and C exactly. We'll only get the ratio of A to B to C. But otherwise, if we know any 3 of these 6, we can solve exactly for the missing 3. So we did this with a triangle that looks fairly regular. What happens if we have an obtuse triangle? What is an obtuse triangle? An obtuse triangle looks something like this. It's got one angle that is greater than 90 degrees. So let's label these just like we did before. Call this alpha, beta, and gamma, and then sides A, B, and C. So in this particular case, how do we write sine of alpha? Well, here we do a procedure very similar to what we did over here. We're going to make a line that is perpendicular to one of these sides. In this case, I'm going to do exactly what I did here and drop a perpendicular to B. And this is going to be called x, just like before. So now I've created a right triangle right here. So now I can very easily write sine of gamma is equal to the opposite side, x in this case, not c, x over a. So now I got one part, just like I had before. But how do I get sine alpha? Well, let's make another placeholder. Let's call this angle here theta. And just like x, theta is going to go away very quickly. So here we can say that sine of theta is equal to the opposite side, x, over the hypotenuse c. Now we know that all theta is 180 degrees minus alpha. That's all it is. It is 180 degrees, which is this line here, minus this angle here, alpha. And theta is 180 degrees minus alpha. So now we can write that sine theta is equal to x over c, or that sine of 180 degrees minus alpha is equal to x over c. These two are the same because of this equation over here. Now here's where it gets tricky. We need to use an identity. There's a trigonometric identity that says that the sine of 180 degrees minus an angle is equal to the sine of that original angle. Now using this identity up here, we know that sine of 180 of theta is equal to sine of alpha. So we get that sine alpha is equal to x over c, just like we had before. Now from here we can go just like we did here and compute all the rest of the values. Now let's look at one special case. Let's say that alpha, or rather gamma, is equal to 90 degrees. So what does that triangle look like? Let's take this triangle and draw it in such a way. Let's draw it in such a way that this angle gamma is 90 degrees. And then we have the same angles as before, alpha and beta. And then the same sides as before, A, B, and C. So this triangle is basically this triangle with this side pushed in so that gamma is equal to 90 degrees. Well, in this case, let's write out the law of sines. So we have that sine alpha over A is equal to sine, let's say gamma, over C. Now, if gamma is equal to 90 degrees, then we know that sine gamma is equal to sine of 90 degrees. Now, when you have sine of 90 degrees, we know that that is equal to 1. So take this and plug it into this equation, and we come back to 1 over C is equal to sine alpha over A. Let's rearrange this, and what do we get? We get that A over C is equal to sine alpha. Now if you notice, this equation is exactly the same as this equation. And this triangle is exactly the same as this triangle. And all we did was take gamma and push it in to make a 90-degree angle. So what you can think of is that when you have a right triangle, that is simply a special case of the law of sines. Thank you for watching. I hope you found this micro lesson interesting. If you did, please like and share this video and subscribe to stay up to date on future micro lessons.